Let's look at solving some logarithmic equations. So first example, let's look at log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. For our first step, we'll combine both of the logs on the left-hand side of the equation using a log property. We want to combine them into a single log. So we'll use the log property where when we're adding two logs, it becomes the log of a product. So we can rewrite this as the log base 5 of the product of x plus 6 times x plus 2 equals 1. So let's multiply out x plus 6 times x plus 2. Log base 5 of x times x is x squared, x times 2 is 2x, 6 times x is 6x, 6 times 2 is 12, equals 1. Combining like terms, we have log base 5 of x squared plus 8x plus 12 equals 1. Next, we'll convert to exponential form. So we can write this as 5 to the first power equals x squared plus 8x plus 12, or simply 5 equals x squared plus 8x plus 12. And then we'll solve for x. We'll start by subtracting 5 from both sides of the equation. So 0 equals x squared plus 8x plus 7. We'll factor. So we're looking for numbers that multiply to 7 but add to 8. We can use positive 7 and positive 1. So we can factor this to x plus 7 and x plus 1. We'll use the zero product property and set x plus 7 equal to 0 and x plus 1 equal to 0. Just rewriting that so we can see that at the top of the screen. And then we'll solve each of these equations to get x by itself. So I'll start by subtracting 7, and we get x equals negative 7. Subtract 1, and get x equals negative 1. So let's look at our original equation again. We had log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. So if our potential solutions are negative 7 and negative 1, we need to remember with logarithms, an argument cannot be negative. So if we're looking at x equals negative 7, if we put that into our first argument of x plus 6, negative 7 plus 6 equals negative 1, we have a negative argument. So that means negative 7 is extraneous and it's not a solution. Let's test out our other solution. X is negative 1. Let's test it in x plus 6. Negative 1 plus 6 gives us 5. That's positive, so that's good there. Let's test it in x plus 2. Negative 1 plus 2 is 1. That's also positive. So x equals negative 1 is a potential solution. It doesn't matter that x is negative. What matters is that the argument of a log is not negative. But it's still also good to check the solution fully in our original equation. So let's check x equals negative 1. Log base 5 of negative 1 plus 6 plus log base 5 of negative 1 plus 2, does that equal 1? So log base 5 of 5 plus log base 5 of 1, does that equal 1? Well, log base 5 of 5 is 1. Log base 5 of 1 is 0, and 1 plus 0 does equal 1, so that checks out, and x equals negative 1 is our solution. Or we can write it in a set as like our solution set is actually negative 1. Let me add the negative that I left off, so negative 1. Let's look at a second example. The natural log of x equals the natural log of x plus 6 minus the natural log of x minus 4. First, we'll combine the two logs on the right-hand side into a single log using a log property. We'll use the log property that the difference of two logs can be combined into the log of a quotient. So we can rewrite this as the natural log of x equals the natural log of x plus 6 over x minus 4. And now, because we have two logs, we have a log on each side of the equation, that logs have the same base, we can essentially ignore the logs and set the arguments equal. This is equivalent to what we had with exponentials. So we can ignore the logs and just set x equal to x plus 6 over x minus 4. Now we'll solve for x. To do this, I'll find my LCD, my least common denominator. In this case, it's x minus 4. And I'll multiply both sides of my equation, or all of my terms, by x minus 4. I have x times x minus 4 equal to, now my x minus 4's on the right-hand side cancel and leave 1's. So on the right-hand side, I'm left with x plus 6. And now I'll multiply. X times x is x squared. X times negative 4 is minus 4x equals x plus 6. I'll subtract x from both sides, and I'll subtract 6 from both sides. So now I have x squared minus 5x minus 6 equals 0. We have a quadratic equation. This can be factored. I'll be looking for numbers that multiply to negative 6 and add to negative 5. That is negative 6 and positive 1. So this factors to x minus 6 times x plus 1. It still equals 0. We'll use the zero product property and set each factor equal to 0. So x minus 6 equals 0, or x plus 1 equals 0. We'll solve each equation for x. I'll add 6 to both sides here. X equals 6. I'll subtract 1 from both sides here and get x equals negative 1. These are potentially our solutions, but remember, no argument in the original equation can be negative. And this first logarithm, the natural log of x, we're putting x directly in as the argument, and we have a negative x. So negative 1 is an extraneous solution and cannot be our solution. So right now, our only real potential solution is x equals 6. We're still going to check this in the original equation. So the natural log of 6, does that equal the natural log of 6 plus 6 minus the natural log of 6 minus 4? The natural log of 6, does that equal the natural log of 12 minus the natural log of 2? The natural log of 6, does that equal the natural log of 12 divided by 2? Yes, the natural log of 6 does equal the natural log of 6 because we're dividing. So x equals 6 is my solution, and I can write it as a solution set, or I can write x equals 6. Third example, 2 times log base 5 of x equals log base 5 of 9. So here we'll use the log property where we can take that 2 that's out in front and bring it up to be an exponent on the argument of the log. So we can write log base 5 of x squared equals log base 5 of 9. And now we have both sides as logs with the same base, and we can ignore the logs and set the arguments equal. So we can write x squared equals 9. And we'll solve for x. So we'll take the square root of both sides, and x equals positive or negative 3. Again, remember, we need to make sure all arguments of the logs in the original equation are positive. And in that original equation, we're substituting x directly in as an argument. So we cannot put that negative 3 in. So I'm crossing out the negative, and the only potential solution is x equals 3. We will still check it. So 2 times log base 5 of 3, does that equal log base 5 of 9? Log base 5 of 3 squared, does that equal log base 5 of 9? Log base 5 of 9 does equal log base 5 of 9, so that checks out. And x equals 3 is our solution, or we can write it as a solution set.